let's start with the probability. Probability, in other words, it is likely to be. We use this for uncertainty conditions or situations. Like here, I may pass the exam. It may pass or may not be. It may rain. We can't say exactly whether it will rain or not. There is a chance of opening the lockdown very soon. So there is a chance. But we are not sure. We are not so sure. There is no 100% sure. We cannot guarantee. So that is uncertainty situation. So we use this word probability in uncertainty situations. This probability is used in many applications, like in astronomy, like in many research work, in medicine, in science, many things. So here, let's take an example. In tossing a coin, we may get here head or tail. This is the possible outcomes. These possible outcomes, collection of these possible outcomes, we call here sample space. We need to know some of the terminology that we use here. So this head and tail, these are the outcomes we call event. Okay, these head and tails. Okay, head and tails are called event. Event is denoted by E. Okay. So here, if I say probability of getting head in tossing a coin, there is one head, possible outcome is 2, so answer will be 1 by 2. So the formula we say here, probability of an event E equal to here number of favorable outcomes. By total number of possible outcomes. By number of possible outcomes. So when you say here probability of getting head, in that case number of favorable outcomes. Out of these two, how many are favored to head? That is, we have only one head, so number of favorable outcome is 1. Then here total number of possible outcomes. Total number of possible outcomes is here is 2. So probability of getting head is 1 by 2. Now let's see some rules. You need to know here some rules, and we can say rules, not exactly rules, but some points. Okay, you need to know some tips. Number 1, probability of a sure event is 1. Sure event means sure to get. For example, in throwing a die, probability of getting a number less than 7. When you throw a die, will you get a number less than 7? Yes. So it means sure to get number less than 7. So that is sure event. For such thing, probability is 1. Number 2, probability of an impossible event is 0. Impossible. For example, a number greater than 7. That is not possible. So the probability of getting a number greater than 7 will be 0. And number 3, sum of all the probabilities of all the events in a sample space is 1. For example, say here, sum of all the probabilities of all the event. What are the event we have here? This one we call here event. I already said this one here event. So here, we have here two event. Probability of getting head, how much we say? 1 by 2. Like that, probability of getting tail also 1 by 2. If we add 1 by 2 plus 1 by 2, we'll get here 1. Half plus 1 is 1. So like that, the sum of the probabilities of all the events in a sample space is 1. Like here, probability of getting 1, probability of getting 2, 3, 4, probability of getting 5, probability of getting 6. If we add all those probabilities, we are supposed to get 1. So that is the 1 point. And number, let's write one more here. Probability of an event must be, or should, of an event should lie, okay, between 0 and 1 inclusive. So here, probability of an event should lie between 0 and 1. It can be 0, it can be 1, it can be anything in between this 0 and 1. That means this probability of an event, okay, this probability of an event, it is greater than this 0, okay, 0 is less than, okay, less than or equal to probability of this event E. So this must be less than or equal to here 1. So probability can be equal to 0. This can be greater than 0, or this probability can be less than 1. It can be equal to 0. So like this, probability should lie between 0 and 1. It can be 0, it can be 1, it can be anything in between this 0 and 1. So we can say therefore like this. Now with this only we can start this probability. Let's see here some examples or some exercise. Let's start from here. A bag contains 4 red and 6 black balls. A ball is taken out of a bag at random. The probability of getting a black ball is. A bag contains 4 red and 6 black balls. A ball is taken out of the bag at random. At random means without choosing, just picking. Okay, not even looking. Okay. The probability of getting a black ball is probability of getting a black ball. Now we have red and black altogether. How many? 4 plus 6. It is 10. 10 balls. We have 10 balls here. 4 red and 6 black. We have here 10 balls. A ball is taken out from the bag at random. Just taking out. Probability of getting a black ball. Probability of getting a black ball. So you can use here this formula, what we have written here before. Probability of an event E is equal to number of favorable outcomes divided by total number of possible outcomes. So here, number of favorable outcomes. This is for the probability. Probability of getting what? Black ball. Probability of getting black ball. How many black ball are here? 6. So probability of getting black ball, okay, it must be equal to here total number of favorable outcomes. Total number of favorable outcomes. Then here total number of possible outcomes. So favor out of this 10, how many are favor to black? There is 6. Then total number of possible outcomes. Total number. How many possible outcomes are there? Altogether here 10. So we can cancel. So we get here 3 by 5. So probability of getting black ball is 3 by 5. This MCQ, the first question. So that's why we are doing. This is the first question. Okay, that's why we are writing here properly. We'll just do here shortcut. Okay, so at least you should know. You need to write in exam. Even if we are not going to write this one again and again everywhere, but in exam you need to write, because in exam you will be doing only few questions, 1 or 2 questions, so you have to write. So answer is how much? 3 by 5. A die is thrown once. The probability of getting a number less than 3. A die is thrown once. Die. Die is a singular form of dice. Okay. So here the probability of getting a number less than 3. When you throw a die, what are the possible outcomes? So those are possible outcomes. Maybe 1, 2, 3, 4, 5, 6. I hope you know dice. A die, that's cube. Like this. Like here, it is marking there. It is, for example, okay. So something like this, it is marking. So this is here die. So it has 6 faces here. That 6 faces we find marking like this, 1 to 6. These are the possible outcomes. So probability of getting a number less than 3. How many numbers are there less than 3? So it is only 1 and 2. So answer is we have 2 by 6. 2 by 6 means it is 1 by 3. Okay. So answer is 1 by 1, 1 by 3. Next one. A bag contains 5 red balls and some blue balls. If the probability of drawing a blue ball from the bag is thrice that of a red ball, then the number of blue balls in the bag is. Listen to the question carefully. A bag contains 5 red balls and some blue balls. 5 red, okay? 5 red balls and some blue balls. Blue balls, we don't know how many, okay? So here, let's take here X. If the probability of drawing the blue ball, okay, from the bag is thrice that of red ball. Probability of getting here blue ball means together will be how much is 1? 5 plus X. So that means probability of getting blue ball will be number of blue ball is X, favorable outcomes is X, total is here 5 plus 3. Probability of getting here this red ball will be how much here? 5 by 5 plus 3. This is the probability of getting blue ball. This is the probability of getting red ball. So according to the question, what does it say? If the probability of drawing a blue ball from the bag is thrice that of a red ball, thrice, 3 times, okay, 3 times that of the red ball, then the number of blue ball in the bag. So the probability of getting this blue ball is 3 times of this. 3 times means we can say it is equal to, we multiply with 3. So from here, this 5 plus X, we can cancel away. That means we get here X value 3 5 is 15. So X is the number of blue ball. So here the question is asking the number of blue ball in the bag. So the number of blue ball in the bag is around 2, this 15. The next one here. 2 dice are rolled once. 2 dice. The probability of getting a number on 2 dice whose product is a perfect square. Question, this type of question usually it asks in exam. Okay. So here 2 dice are rolled once. When we roll 2 dice, how many possible outcomes will you get? That is the first thing. So when you, how much do you think? If you roll here like this type 2 dice, if you roll, how many possible outcomes? That will be here 6 6 36 like this. Here is one example. On page here 321. You can open and check. So here, look here, 2 die. One is gray, another is here, let's say blue. When you when you roll, both you may get 1 1. Or the blue may be 1, then gray may be 2. Blue may be 1, gray may be 3. So like that here, we may get any one of these. Altogether we have 36. 6, 6, 6, 6 are 36. We have 36 possible outcomes. So if it is here question answer, we have to write it that, okay? But here for as of now this is MCQ, so by looking there we'll be doing. So here the question asking, two dice are rolled once, the probability of getting such numbers on two dice whose product is a perfect square. Probability of getting such numbers on two dice whose product is a perfect square. On two dice we have here 2 outcome here. The product of these two must be perfect square. So for example 1 1 is 1. 1 is a perfect square of 1. And any other here 2 2 is 4. 3 is this one, 4 4 is 16, 5 5 is 25, 6 6 is 36. There is no other. Oh wait, here is 1. 4 1. 4 1 is 4. 4 is a perfect square of 2. 1 into 4 also 4 is a perfect square of 2. Okay. Then any other? No other. So that means how many possible outcomes are there? This 6, 7, 8. We have 8 possible outcomes. What are they? Here 1 1. Then here said here this one 1 4. Okay. Then here 4 1. Then here 2 2. Then 3 3. 3 is 9, 4 4. Then 5 5. Then here 6 6. So like this we have these possible outcomes. That means the probability of getting a number whose product is a perfect square will be number of favorable outcomes. This 8, we have here 8, together here 36. So here how much we are getting? 4 2 is 8, 4 9 is 36. So this is answer. Answer is 2 by 9. Next, number 5. A card is drawn at random from a well-shuffled deck of a playing card. From a well-shuffled deck of playing card. So you need to know how many cards are there in a deck. Okay. The probability that the card drawn is neither a king nor a queen. Neither means not king, not queen. Okay. So in playing card, there are 52 cards. We have 4 suits. 4 suits. Those are, you know, let's say heart, kind of like this. Then here diamond is here like this. Then here spade can be so kind of, you know, like this. Then here club is here like this. So from here, you know, these two are red color. So this here red, and these two are black color. This is black. So 2 are red and 2 are black. So this one is start with A. Okay. Then it will come here 2, 3, 4. It will go on like this. Then here 10. Here Jack, Queen. Here King. Like this. Then here for diamond also, you start with A, okay. Then here 2, 3, 4. E is ace, okay. We call here ace. So this one here 10, Jack, Queen, King. For this also, starting with A, it goes on like this. 10, Jack, Queen, here King. Here also start with A, and here 10, here Jack, Queen, here King. So here this Jack, Queen, King, these 3 we call here face card. That means here in each suit it has 3 face card. So 3 4 is 12. So we have 12 face card. When you say face card, it is the card that has human face. This Jack, Queen, King. And this E is we call here ace. So in each suit we have here 13 cards. Starting with E. E is, you can think 1, 2, 3, 4 up to 10, then Jack, Queen, King. So we have 13 cards. So altogether here 13 into, together 13, here 13, here 13, here 13, together here 13 into 4, we get here 52 cards. Remember, out of these 52 cards, here 12 of them are face card.
Now let's go back to question number 5. A card is drawn at random from a well-shuffled deck of playing cards. Probability of the card that drawn is neither a king nor a queen. So, probability of getting a card which is not a king, not a queen. So that means how many cards are there? That is not king, not queen. So here we know here total number of cards is here 52. So number of king and queen equal to, there are 4 queen and 4 king, altogether here 8. That means how many cards that is not queen, means here number of, is a favorable outcomes equal to, from 52 we have to subtract this 8, so we get here 44. So there are 44 cards which is not queen, not king. So that means therefore probability, okay, of this event E, okay, it must be equal to number of favorable outcome is 44. Means there are 44 cards that are not king and queen. So out of here 52. So we can cancel here, get like this. So answer is here 11 by 13. So probability of getting a card which is not king, not queen is 11 by 13.
Let's continue here. Let's see this statement. What is this? We fill in the blank. Complete the following statement. Probability of event E plus probability of the event not E. For this, the sum of these two probability will be 1. As we know, the sum of all the probability is 1. So here, this is like, for example, say, in tossing a coin, probability of getting head plus probability of not head together will be 1, because it has only head and tail. Not head means will be tail. Here also same thing. Not E means it will be the other one. Number 2, probability of an event that cannot happen is this is impossible event. Okay, we call this one, such an event is called impossible event. So for that such thing here, the probability will be how much? 0. So probability of an impossible event is 0. So such an event is called impossible event. Next, number 3. The probability of an event that is certain to happen is 1. Certain to happen means sure to come. Okay, such an event is called sure event. Sure event. Next one. The sum of the probabilities of all the elementary events of an experiment is 1. Just now we have said sum of all the probability in a sample space is 1. The probability of an event is greater than or equal to 0. Is equal to 0 or greater than 0. And less than or equal to here 1. This means it should be always in between 0 and 1, inclusive. Number 2. Which of the following experiment has equally likely outcomes? Number 1. A driver attempts to start a car. The car starts or doesn't start. We have to explain which of the following experiments have equally likely outcome. Whether they have equally likely outcome or not, we have to see for each and every statement. The first one, a driver attempts to start a car. The car starts or doesn't start. Now it seems to have only 2 events, the car start or not start. But here, whether the car start or not, in this case, it depends on so many factors. Like if the car is a very old one, or if the car is very new, it is likely to start. If the car is very old, it is likely not to start. So it depends on many other factors. Okay, if there is no fuel, it will not start. So there are many factors. So in this case here, this one, they do not have equally likely outcome. The first statement has no equally likely outcomes. Okay. Number 2, a player attempt to shoot a basketball. She or he shoots or misses the shot. This also, whether he shot or he missed, it depends on some factors. Like here, if the player is very far, standing very far away, it is likely to miss. If it is very close, or a professional player, if it is professional player who is toasting here, they can shoot it easily. So it depends on some factors. If I shoot, surely will miss. So here it depends on some factors. Then here so they do not have equally likely outcomes. Next, a trial is made to answer a true-false question. The answer is right or wrong. A trial is made to answer true or false. True or false means it is either true or false. Only two, they have equally likely outcome. In this case, equally likely outcome. So we'll say number 3 has equally likely outcome. So whether it is right, the answer is right or wrong. It has only two events. Either it will be right or wrong. If not right, wrong. There is no other. So in this case here, this has equally likely outcome. A baby is born. It is a boy or a girl. When a baby is born, surely it is a boy. If not boy, it will be girl. There is no other. When they grow up, they become like something like tomboy. That is another case. But when at the time of birth, if it is boy, it is boy. If not boy, it will be girl. There is no other. So this has equally likely outcome. Okay. So we can say this number 3 and this 4. These two have equally likely outcome. This thing. Next one, number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of a football game? Why is tossing a coin considered to be a fair way of deciding who will start the game? To find out that one, usually we toss a coin. Why that one considered as a fair way of deciding who to start? So because tossing a coin has only two possible outcomes, either head or tail. So one event is not favor of the other, means head is not favor of the tail is not favor over head. So it can be anyone here, which means one do not have more chance of coming. Both have equally likely outcomes. Okay, so that's why it is a fair way of deciding. This tossing a coin is a fair way of deciding. Next, number 4. Which of the following cannot be probability of an event? Which of the following cannot be the probability? So here 2 by 3 minus 1.5, 15%, 0.7. See 15%. If we say here 15% is equal to how much here? This will be 15% means it is 15 by here 100. So by cancelling, you will get here 3 by 20. So from all these here 4 options, you see here the only odd one is this here, negative. Probability cannot be negative. It cannot be less than 0. It should be in between 0 and 1. Minus means it is less than 0. So this negative, this will be the answer. If negative not there also, suppose if this same question if asked and without this minus, okay, that also answer will be this only. You know the reason? Find out the reason. Okay. Next one here, number 5. Think about that, the reason. If probability of an event E, this one you have to read as probability of an event E equal to 0.05. What is the probability of not E? Probability of getting E and not E together will be 1. So that means the other one you can subtract from 1. So we can say probability, okay, of not E. Of not E, you can write E on here like this with a bar here like this. This means not E. E is here, not E. So is equal to, this can be 1 minus 0.05. So this one we can say how much here? 0.95. Okay. A bag contains lemon flavor candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy, a lemon flavor candy? Now a bag contains lemon flavor candies only. Only lemon flavor. So without looking, when she pick one candy, so here the question is asking, what is the probability that she takes out an orange flavor candy? It contains only lemon flavor candy. So will it get orange? No, will not get orange because it has only lemon. So the probability of getting an orange flavor candy is 0. This is impossible even. It is not possible. Okay. A lemon flavor candy. So this will be only 1. Probability of getting lemon flavor candy will be 1. There's nothing to solve. Just only this. Next one here, number 7. It is given that a group of 3 students, in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? Once again here, it is given that in a group of 3 students, the probability of 2 students not having the same birthday, probability of 2 students not having the same birthday is this. What is the probability that 2 students have the same birthday? So having same birthday, not same birthday, if we add the probability of these two, we are supposed to get 1. That means you can find the probability of having the same birthday by subtracting this from 1. Okay, so we can just write here like this. This is number 7. So probability of not having the same birthday is this. So probability of having the same birthday, okay? So just right here, probability of having the same birthday equal to, as I said, you can subtract from 1 minus, how much here? 0.992. If you subtract this, then how much will get? 0.008 will get this. So this is the answer. Next one, number 8. A bag contains 3 red balls, 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red, not red? Now here it has here 3 red balls, 3 red balls. And how many here? 5 black balls. Together we have 8 balls. The question asking the probability that the ball drawn is red. A ball is drawn at random. At random means just without choosing, even without looking, just picking. Okay, 1. So the probability of getting red will be how much then? Probability of getting here red ball. Okay, red ball equal to, let's write the formula. We say here this one, number of favorable outcomes divided by total number of possible outcomes. Total number of possible outcomes. So is equal to, so we have here 8 outcomes, 8 balls. So that means the 8 possible outcomes are there. Out of these 8 can be anyone. So number of favorable outcomes. Favorable outcomes is here. Out of these 8, how many are favor to red ball? That means out of 8, only 3 are red. So that means here 3 cannot cancel. So answer is this. That's it. Next here, number 9. A box contains 5 red marbles. Okay. A box contains 5 red marbles. then here 8 white marbles, and here 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? Number 1 is red, then white, then not green. So here we have 5 red, 8 white, and 4 green. That means here together total is how much? Here total number of, this is balls, right? Marbles, number of marbles equal to how many here? And here how much? 17. 17. Next, what is the question asking? What is the probability that the marble taken out will be red, white, not green, red? How many red are there? Okay, number 1. So probability of getting here red ball, okay, equal to how many red? Here 5. Together total is how much? Here 17. So answer is only this. Then second one here, probability of getting white marble, okay, white is, we have here 8 by here 17. Number 3, probability of getting not green, probability of getting not green means how many balls are there that is not green? Out of these 17, only 4 of them are green. That means how many are not green means these 2. So here 13. So answer is 13 by 17. Every time we don't need to write this formula, but in exam you have to write, as I said earlier also. In exam you will be doing only few questions, 1-2 questions, so you need to write. But now when you practice, you don't need to write everywhere, okay? A box contains 5 red marbles, 8 white marbles, and 4 this one. Number 9. A piggy bank contains 150 pice coins, 50 rupees 1 coins, 20 rupees 2 coins, and 10 rupees 5 coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be 50 pice coin, will not be a rupees 5 coin? So here total number of coins. So first here you see here total, let's find out total number of coins. What are the number of coins here? It contains here 150 pice coin, okay? So here 150 pice coin, okay? 50 pice coin. Then here this one 50 rupees 1, okay? Rupees 1 coin, okay? Then here plus here 20 rupees 2 coin, and plus here 10 rupees 5 coin. That means together how many we have? 100, 70, 80. So we have here 180 coins. So when this piggy bank is kept upside down, one coin will be falling. So that coin is, that which coin will be falling, it has equally likely outcomes. If it is equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be 50 pice? So when you keep upside down, one coins will be falling, and it has equally likely any one of these may fall. So here the question is asking, what is the probability that the coin will be 50 pice coin? So how many 50 pice coin here? We have 100 out of 180. So answer will be number 1. Okay, probability of here 50 pice coin. Okay, it will be how many 50 pice coin? 100 by 180. By cancelling, we can say here 5 by 9. Okay. Next, number 2. That's number 1. will not be rupees 5 coin. So probability of not rupees 5 coin. Okay, probability of getting not rupees 5 coin. Okay, so how many are there which is not rupees 5 coin? Out of these 180 coins, only 10 of them are rupees 5 coins. That means 170 are not. So here you can write here number of favorable outcomes or number of coins, not 5, not rupees 5, divided by total number of possible outcomes. Okay, whatever you can write in the exam, but as of now you can just write here that is together 180, only 10 are rupees 5 coins, so we can subtract divided by total here 180. So that means there are 170 coins which is not rupees 5, 170 coins are not rupees 5. So 170 by 180. So cancelling, we get here 17 by here 18. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from the tank containing 5 male fish and 8 female fish. What is the probability that the fish taken out is a male fish? So here in the aquarium, here how many fish we have here? 5 male fish and 8 female fish. So together that is here how many fish? 13 fishes. Okay. So from there 5 of them male, then here 8 of them female. So what is the probability that the fish taken out is a male fish? Male is here only 5 to get out of here 13. So answer is only this. Okay. Then next one, number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the number 1, 2, 3. Okay, then these are equally likely outcomes. What is the probability that you will point at 8? So how many possible outcomes are there? 8, 1, 2, 3, 4, 5, 6, 7, 8. So out of 8, 8 is only single here, one sector. Okay, only 1 8 here. So answer will be only 1 by 8. Then next one, an odd number. How many odd number are here? So here 1 is odd number, 3 odd number, 5 odd number, 7 odd number. Out of 8, 4 of them are odd number. So here 4 by 8 is equal to 1 by 2. A number greater than 2, 6 of them are there which is greater than 2. So that means here 6 by here 8. By cancelling we get here 3 by 4. Next one, a number less than 9. Nothing is more than 9. Nothing is 9. All are less than 9. So that means here sure to get. So probability will be only 1. You can write 8 by 8 equal to 1, or you can write directly here 1, because all these numbers are less than 9 only. Sure to get. So that is sure event. So will be 1. A die is thrown once. The probability of getting a prime number. So this also we can just do here. When you throw a die, okay, what are the possible outcomes? Possible outcomes are, what are they? Let's just do here 1, 2, 3, 4, 5, 6. You know die, you remember? That die, that cube. It is here, it is marking here some numbers, okay. So here like this. So when you throw, you will get one of the face. You may get 1, 2, or 3, or 4, or 5, or 6. You may get any one of that. So a prime number, probability of getting a prime number. So you need to know what are these prime. Prime numbers are the numbers that have only 2 factors. That is 1 and the number itself. In other words, which can divide only by 1 and the number itself. So from here, prime numbers are these 2, 3, 5. These are prime numbers, because 2 is divisible only by 2 and 1. 3 also is divisible by only 3 and 1. 5 also. But 6 means is divisible by 2 also, by 3 also, so many. So here 2, 3, 5, these are the prime numbers. So a prime number, there are 3 prime numbers, so answer will be 3 by 6. By cancelling, we will get here 1 by 2. Number lying between 2 and 6. Between 2 and 6, what numbers are there between 2 and 6? These three numbers, 3, 4, 5. So, a number lying between 2 and 6, the probability of getting a number lying between these two will be here 3 by 6. So, this also 1 by 2. An odd number. An odd number. So, how many odd number are there? We have here 3 odd number, 1, 3 and 5. These are the odd number. So this also answer will be here 3 by 6, which is equal to 1 by 2. Coincidentally, answer is all 1 by 2. Next one here, number 14. A card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. A king of red color. So how many king of red color are there? You need to remember what we have shown last time about that playing card here. It has here 4 suits: heart, diamond, spade and club. So here 2 of them, this heart and diamond, these 2 are red, and whereas these 2 are black. So here it has, each suit has 13, all 13, and together it has here 52 cards. You need to remember this. Now come back to this. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. A king of red color. How many king of red color are there? Okay, there are 2 king, right? So here number, this is 13, not 13. 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. So, total number of cards, or we can say total number of possible outcomes equal to here 52, because there are 52 cards. So number 1, a king of red color. A king of red color. So here probability of getting king of red color, you can still write here, or PE you can write, okay? So we can say here king, or let's say here probability of, let's say, red king equal to. So there are 2 king, 2 red king out of 52 cards. So answer is here 1 by 26. Next here number 2. A face card. How many face cards are there? You need to remember, last time we said face card. Each suit has 3, so together towards the 12 face card. Okay, so this is here a face card. Face card equal to. There are 12 face cards out of 52. So we can cancel. 4 3s are 12, and 4 1s are 4, 4 3s are 12. So answer is 3 by 13. Next one. A red face card. So probability of getting red face card equal to. Red face card. How many red face cards are there? Out of 12, 6 is red, 6 is black. Okay, this is red, and 6 is this one. So that means how many red face cards are there? There are 6. So here 6 red face cards are there out of 52. Okay, so that means here 3, here 26. Only this. Next, number 4. A jack of heart. A jack of heart. So probability of getting, okay, jack of heart. Equal to jack of heart. How many jack are there in a heart? We have here that 4 shoots. That is here heart, diamond, spade, club. Okay. So for each here, it has only one jack. For each of them, only one jack. So there is only one jack here. So 1 out of 52 cards. So answer is this. Next one here, number 5. A spade. A spade. Spade. Probability of getting a spade. Equal to. So how many spades are there? 13. Each shoot has 13 cards. Okay. So here 13 by 52. If we cancel, we get here 1 by 4. 13 into 4 is 52. Next one, the queen of diamond. The queen of diamond. This is number 6. Okay. Queen of diamond. So probability of getting the queen of diamond. Okay. So it's equal to, it has only one queen out of 52. One queen of diamond. So answer is only this. Next here, number 15. Five cards. The 10 jack, queen, king and ace of diamond are well shuffled with their face downward. One card is then picked up at random. What is the probability that the card is green? So we have 5 cards. What are they? 10 jack, queen, king and ace of diamond. Diamond. Diamond is what color? Red. So one card is picked at random. What is the probability that the card is queen? So queen, not green, is queen. So here how many queens are there? Only 1 out of 5. So answer is 1 by 5. If the queen is drawn and put aside, what is the probability that the second card picked up is an ace or queen? So if the queen is drawn, suppose when we draw one card at random, suppose we are getting this queen, and that card we keep aside. If we pick again here the second card, okay, what is the probability of getting the ace? So how many ace are there from the remaining? Only 1 out of how many? 4. That queen is keeping aside. Then next one, queen. Already queen here, already we got, that means we will not get any more queen. So probability of getting queen, this queen will be 0 because there is no more queen. Twelve defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. So how many good ones are here? 132. And how many here bad defective one? Here 12. So this one is mixing with this, that means that together is here 144. Okay. Out of this 144, okay, so here how many good ones are here? Good one is only 132. Determine the probability that the pen taken out is a good one. So here number of good one is 132 divided by this. So this is the answer. We can reduce this one here equal to. So we can cancel it with 12. So 12 ones are 12, 12 ones are 12. Then next is here 12 into 12, so answer is 11 by 12. The next one, a lot of 20 bulbs contain 4 defective ones. A lot, just mixing a lot, okay. lottery, like the lottery. A lot of 20 bulbs contain 4 defective ones. 20 bulbs are there, it contains 4 defective ones. Out of 24 are defective. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? How many defective are there? 4. Out of how many? Here 20. So answer is 1 by 5. Suppose the bulb drawn in Roman number 1 is not defective. Suppose if not defective and is not replaced, that means it is keeping aside, okay? It's not defective and keeping aside. Now, one bulb is drawn at random from the race. What is the probability that this bulb is not defective? So one bulb is already given here separately. So that means we have only here 19 bulbs. Out of these 19 bulbs, okay, how many bulbs is not defective? How many bulbs is not defective? The first one is not defective and keeping aside. Before, how many not defective we have? 4 are defective out of 20. That means 16 of them are good one. So out of that 16, one has already kept aside from this Roman number 1. So the remaining only 15. So answer will be 15 by 19. Now question number 18. A box contains 90 days which are numbered from 1 to 90. In one dish, if one dish is drawn at random from the box, find the probability that it bears a 2-digit number. Then number 2, a perfect square number. Number 3, a number divisible by 5. So here in a box, it has 90 dishes, number from 1 to 90. Question asking, find the probability when you pick one ball at random, find the probability that the dish bear a 2-digit number, a perfect square number, and a number divisible by 5. So the first is probability to get a 2-digit number. So then what are the 2-digit numbers here? Now let's see. 2-digit number. Total number of this is 90. It is number from 1 to 90. 2-digit number means it will be from 10. 10 is 2-digit. 9 is 1-digit. 9, 10. So starting from 10, 10, 11, 12 up to 90. So how many are there? That means we have here 81. 81 numbers are there that have 2-digit. 81 dishes are there that have 2 digits. So probability, we know probability of an event E equal to number of favorable outcomes divided by total number of possible outcomes. So number of favorable outcomes. For this here, probability of getting a 2-digit number, how many these are there that are favored to 2-digit? That means here from 10 to 90, that is 81 are there. 81 out of 90, so 81 by 90, we get 9 by 10. In the same way, number 2, asking probability of getting a perfect square number. Perfect square number, so what are the perfect square number there on the disk? That is 1 is a perfect square of 1, 4 is a perfect square of 2, 9 is a perfect square of 3, like that it goes on up to here, 81. So these are the perfect square number. So how many are there then? 1, 2, 3, 4, 5, 6, 7, 8, 9. So number of favorable outcomes is 9 divided by total number of possible outcomes, so we get 1 by 10. The next one here, the total number, the question asking to find the number divisible by 5, probability of getting a dish which is divisible by 5, divisible by 5. So what are the numbers divisible by 5? So this thing, 5, 10, 15 up to here 85, 90. That means altogether there are 18 are there. So answer is probability of getting a number divisible by 5 equal to 18 by 90, because there are 18 numbers, okay, divisible by 5. So answer is 1 by 5. Then here next here number 19. For 19, it's nothing. Look at the question here. This is what is given here.
question number 19. A child has a die with 6 faces shows the letter as given below. That die has 6 faces like this. A, B, C, D, E, A is written like this. The question is asking that this is thrown once. What is the probability of getting A and D? So here probability of getting A. How many are there? How many possible outcomes? How many possible outcomes are there? We can say here 6 are there. A, B, C, D, E, A. So 6 are there. Possible number of outcome is 6. So the probability of getting A, out of these 6, how many are favored to A? We have here 6. How many are favored to A? That means 2. The last one and the first one. So answer will be 2 by 6. Okay, like that. Probability of getting D. How many are D? Only 1. So 1 by 6. So the answer will be like this now. Probability of an event E equal to probability number of favorable outcomes by total number of possible outcomes. Probability of event E equal to number of favorable outcomes by total number of possible outcomes. The number 1 asking the probability of getting A. So as I said here, 2 are favored to A. So 2 by 6, 1 by 3. Then probability of getting D will be 1 by 6. Now next one here, question number 20. In question number 20, here is a rectangle of side 3 and 2, and inside it one circle is there. Here the question is asking, what is the probability that it will land inside the circle with diameter 1 meter? Now this is a circle of diameter 1 meter. So suppose you drop a die at random on a regular. Suppose you drop a die at random on the rectangular region shown in the figure. What is the probability that it will land inside the circle with diameter 1 meter? So when you drop a die here, the probability of landing inside the circle, that is the question asking. Together this area, whole area, this rectangle, so favorable area is this one, only this area of the circle. That means area of the circle divided by this area of the rectangle. That's all. So here, let's see here. So area of the rectangle equal to 3 into 2, length into breadth, here 6. Area of the circle is pi r square, we get like this. So probability of getting, probability that the die will land inside the circle equal to area of the circle divided by total area of the rectangle. So we get the answer here, pi by 24. Next, 21. A lot box of 144 ball pen of his 20 are defective and others are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draw one pen at random and give it to her. What is the probability that she will buy it? She will not buy it. So she will buy if it is good. How many good are there? 20. Okay? Oh no, 20 are defective. How many are there? A lot consists of 144 ball pens, of which 20 are defective and the others are good. Nuri will buy a pen if it is good, but he will not buy if it is defective. The shopkeeper draws one pen at random and give it to her. What is the probability that she will buy it? She will not buy it. Now she will buy if it is good. So that means how many pens are there? How many are good? You have to see. A lot consists of 144 ball pens, in which 20 are defective. Together is 144, 20 are bad, defective. That means how many are good? 124. So answer is 124 by 144.
She will not buy. That means 20 are defective, so 20 by 144. So the answer comes here just like this. 124 by, this is good one, number of good pen, and together, okay, 31 by this, and not buying, bet this, those defective one, okay, number of defective pen 20 by 144, it comes like this. Next here, question number 22. Refer to example 13, complete the following table. Example 13. In example 13 here, 2 dice, 1 blue and 1 gray are thrown at the same time. Write down all the possible outcomes. So here, all the possible outcomes are like this. When 2 dice are thrown, we may get any one of these possible outcomes. So together we have here 36 possible outcomes. So here, what the question asking exactly is, question asking to find the probability of getting the sum 2 on 2 dice, probability of getting the sum 3 on 2 dice. So probability of getting the sum 2 on 2 dice. So how many outcomes are there whose sum is 2? So for that here, only one outcomes here. 1 plus 1, 2. Out of these 36 possible outcomes here, only one is favor to the sum 2. 1 plus 1, 2. No other. So answer is 1 by 36. So that one is already given here. So we have to fill up all this. So for this, let's see here. So here this 1, 1. Only this, so that's why 1 by 36. Possible outcomes is there are 36. Then again next is, whose sum is here 3. Sum 3. Sum 3 means here 1, 2, 2, 1. Only these two. So answer is 2 by 36. So you can cancel 2 by 36. So we will get 1 by 18. Then again here, whose sum is 4. 4 is here is 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, only this. So that means 3 by 36, we can cancel. So like that, whose sum is 5, there are 4, so we are doing like this. Whose sum is here 12. 12 means here, this one here, let's say 10, whose sum is here 10. 10 is here, there are only 3. Who are they? You see here, 5 plus 5, 10. 6 plus 4, 10. 4 plus 6, 10. So only 3, that's why here 3 by 36. We can still cancel. Whose sum is here 12. 12, only this one, 6 plus 6, 12. This is the only. So 1 by 36. Number 2. In number 2, the question asking, have a look at the question. On the top of the page, a student argued that there are 11 possible outcomes, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Therefore, each of them has a probability 1 by 11. Do you agree with this argument? Justify your answer. So, there are 11 possible outcomes. No, they are not 11. Here we say here, how many? 36 possible outcomes. Okay? And we have different here probability. Okay? For different sum. Okay? So here is, say each of them has a probability 1 by 11. So that is wrong. See? All say are different, all are not 1 by 11. And we have 36. So you say, the student argued that there are 11 possible outcomes. Therefore, each of them has a probability 1 by 11. So it is wrong. So obviously, the argument is wrong since the total number of possible outcomes is 36. Okay, next here 23. The total number of possible outcomes is here 8. What are they? When 3 coins are tossed, you'll be getting like this, head, 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 tail, or like this, or like this, or tail, tail, tail. We have together 8 outcomes here. When 3 coins are tossed, okay, we have 8 outcomes. So, probability of losing, according to the question, you will lose if you do not get the same result. Like, if you get here 8, head, 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 tail, 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 only these two, you will be winning. So that means probability of losing game will be, out of these 8, see 1, 2, 3, 4, 5, 6, 6 are there. So 6 by 8, answer 3 by 4.
Next here, question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif win if all the tosses give the same result, that is 3 head or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So in tossing this coin 3 times, if he gets the same result, all head or all tail, he is winning, otherwise he is losing. So when we toss 3 coins, okay, when we toss 3 coins, or when we toss a coin 3 times, we may get like this. These are the possible outcomes: head, 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 tail, head, tail, head, tail, head, head, tail, tail, head, like this, or tail, 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 like this. 8 possible outcomes are there. He is winning only when he have 3 head, 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 3 head, or 3 tail, otherwise losing. So that means out of this here 8 possible outcomes, okay, how many are favor to losing? 1, 2, 3, 4, 5, 6. So answer is 6 by 8, so 3 by 4. In question number 24, here, a die is thrown twice. This die is thrown twice. A die is thrown twice. What is the probability that 5 will not come up either time? 5 will come up at least once. So here, first let's see, when a die is thrown twice, is throwing twice, okay? And here is outcome we are noting, and we are getting like this possible outcomes. The first throw, let's say here 1, second throw also 1. First die may be 1, second throw maybe 2, like that, 1, 3, 1, 4, like this. Or the first die here, first throw 2, second throw 1, first throw 2, second throw also 2, like this. Or 3, 1, 3, 2, 3, 3, or 4, 1, 4, 2, like this. These are all possible outcomes. There are 36 possible outcomes. So the question asking here, what is the probability that 5 will not come off either time? So how many times are there 5 is not coming out? So 5, where are 5 here? This one here, all having 5 here. Here also all having 5. So without this column and this row, how many are there? Out of this 36, okay, those the result that has no 5, those are here. Here is 6, 7, 8, 9, 10, 11. So 36 minus 11 equal to 25. So there are 25 outcomes where it has no 5. So answer will be here 25 by 36. So here we get 25 by 36. Then next one here, 5 will not come up either time. The first one is 5 will not come up either time. Next, number 2 is 5 will come up at least once. 5 will come out at least once. So this here not, this is mistake here. So here, according to the question, what does it say? 5 will come up at least once. 5 will come out at least once. It will come out is the at least once. Okay. So 5 will come out here at least once. So at least once means it can be more than 1 also, means here this 5 also can include. That means this 11, okay? So answer is 11 by 36. So there are 11 outcomes where it has at least 1 5. Okay, those are this row, this column, okay, this column and this row, okay, what we said that 11. So answer is 11 by 36. Next here, 25, which of the following arguments are correct and which are not correct? Give reason for your answer. Number 1, if 2 coins are tossed simultaneously, there are 3 possible outcomes, okay. So 2 head, 2 tail, and 1 of each. Therefore, for each of this outcome, the probability is 1 by 3. So this is wrong. When we toss 2 coins, here you say 3 possible outcomes. There are 3 possible outcomes. There are not 3, it's 4. 4 possible outcomes. those 4 possible outcomes are this one. It can be head head, head tail, tail head, and tail tail. 4 are there. That means they said here 3, so it is wrong. So we can say the answer is this. Number of possible outcomes equal to 4. Therefore, the given statement is incorrect. And here in number 2, if a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. So this is correct. When we throw a die, okay, we'll get here. There we don't have only 2 possible outcomes. Possible outcome is 6, okay, but 3 odd and 3 even. So we give like this. Since there are 3 odd numbers and 3 even numbers in a die, the probability of getting an odd or an even is 3 by 6 equal to 1 by 2. Hence the given statement is correct. Number of possible outcomes is 6, but half of them are even, half odd. So 1 by 2. Probability of getting an odd number 1 by 2 is correct.